Hello everyone, I'm presenting Legolas, a novel approach to predict hospital admission in emergency departments using large language models, and I think you'll find this work particularly relevant if you are interested in AI application in healthcare. Let me start with a critical challenge facing modern hospitals. Emergency departments are overwhelmed. Every day they handle unpredictable patients' flow, and overcrowding creates a cascade of problems. Longer waiting time, higher mortality rates, delayed treatments, and enormous costs. Hospital administrators struggle with a fundamental question: how many patients will we need admission today? If you could predict accurately and early which patients will need hospitalization, we could make smarter decisions. Nurses could be scheduled more efficiently. Hospital beds could be prepared in advance. Most importantly, patients' care would improve. Traditional machine learning approaches struggle with the emergency department data. The information is messy and heterogeneous. You have vital signs, symptoms, medication, diagnostic code, all recorded at different times with different frequencies. A patient may report 3 symptoms at one point, or none at another one. Traditional methods force this rich information into a rigid feature vectors, creating sparse representation that lose valuable context. We took a completely different approach. Instead of forcing data into a spreadsheet, we tell stories. Here's they take insights. We convert each patient's journey into a narrative text. For example, imagine white female enters in emergency department by walking 5 minutes ago. Patient was assessed at the triage 2 minutes ago with body temperature equal 37 degrees, and so on. This narrative naturally captures the variety and the multiplicity of the real medical data. Then, and this is the crucial, we fine-tune our large language model, similar to BERT or GPT models, to understand this narrative and predict outcomes. Large language models are pre-trained on massive text corpora. They already understand language patterns, medical terminology, and complex relationships. Fine-tuning leverages this knowledge for our specific tasks. We are not training from scratch. We are adapting a sophisticated tool in a new domain. This is much more efficient than traditional approaches. In terms of results, let me show some numbers. Legolas achieved 76% of accuracy compared to the 66% from traditional machine learning methods, like random forest and XGBoost. We tested Legolas on a mini-cell, a real event log with over 400,000 patients' journeys from the Mimic 4 emergency department dataset. This includes 8 outcome categories, not just admitted or own. Our method handles this complexity naturally through narrative representation. Now, here's something many AI systems lack: explanation. We integrate the integrated gradient algorithm to explain every prediction. We discover fascinating patterns like, in early stages, arrival information and timestamp are most important. As the journey progresses, recent events gain relevance. This isn't just academically interesting, it's a clinical valuable. Doctors can understand why the system recommends admissions, and they can trust or challenge its recommendation. As future work, we are exploring several extensions, predicting which hospital department a patient should go to, incorporating multimodal data like X-ray or ECG, and addressing consent drift over time as disease patterns evolve. Thank you for the attention.